All right, so we pick up here coupon bond yields. Given the yields for zero coupon bonds, we can use equation 6.6 to price a coupon bond. In section 6.1, we saw how to compute the yield to maturity of a coupon bond from its price. Combining these results, we can determine the relationship between the yields of zero coupon bonds and coupon paying bonds. All right, so this is what's important here. Consider again the 3-year $1,000 bond with 10% annual coupons. Given the zero coupon bond yields in table 6.2, we calculate a price for this bond of $11.53. From equation 6.5, the yield to maturity of this bond, right, is the rate that satisfies. So here is the price. Here is the price, which we know already. Here was the coupon. Here was the payments, including the final payment. And here we're trying to solve for the rate or the yield. Okay. So here is the yield to maturity, and we use Excel, and we come up with a yield to maturity of 4.44%. All right, therefore the yield to maturity of the bond is 4.44%. We can check this result directly as follows, and you pop this into here, and you see you come up with the price of $11.53. Because the coupon bonds provide cash flows at different periods of time, the yield to maturity of a coupon bond is a weighted average of the yields. Okay, that's important. It's a weighted average of the yields of zero coupon bonds of equal and shorter maturities. The weights depend in a complex way on the magnitude of the cash flows each period. In this example, the zero coupon bond yields were, as we saw from previous examples, 3.5, 4, and 4.5. For this coupon bond, most of the value in the present value calculation comes from the present value of the third cash flow, right? Because it includes the principal. You see that right there? So the yield is closest to the 3-year zero coupon yield of 4.5%. All right? Because that's providing the most, all right? All right, so another example here. They give you a lot of nice examples here. Yields on bonds with the same maturity. Given the following zero coupon yields, compare the yield to maturity for a 3-year zero coupon bond, a 3-year coupon bond with 4% annual coupons, and a 3-year coupon bond with 10% annual coupons. All of these bonds are default free. So here is the zero, right? A 1-year zero is 3.5%, a 2-year is 4%, 3-year is 4.5%, and a 4-year is 4.75. From the information provided, the yield to maturity of the 3-year zero coupon bond is 4.5%. Okay, see that right there? Also, because the yields match those in table 6.2, we already calculated the yield to maturity for the 10% coupon bond. So we did that already, right? As 4.4. To compute the yield for the 4% coupon bond, we first need to calculate its price. All right? So using equation 6.6, here are the yields from here, right? So the $40 is the 4% coupons, right? And here are the 3-0 coupon yields from here, and we get that price. The price of the bond with a 4% coupon is shown here. From equation 6.5, its yield to maturity solves the following equation. So now we got the price using the zeros. So we now take this price and put it here. Okay. Here's the coupons, and now we're going to solve for the yield to maturity, right? And the yield to maturity comes out to 4.47%. Okay. And So here's the three-year bonds. So coupon rate of 0% is 4.5. A 4% is 4.47, which we got from here, and a 10% is 4.44. Okay, and I think here it is right here. Alrighty, so that's about it. So for a 3-year, here's the 3-year, so that matches, right? So what this example showed, and if you can see here, the coupon bonds with the same maturity can have different yields, right? Depending on their coupon rates. So different coupon rates, right? As the coupon increases, earlier cash flows become relatively more important than later cash flows in the calculation of the present value. If the yield curve is upward sloping, as it is for the yields in example 6.8, the resulting yield to maturity decreases with the coupon rate of the bond. Alternatively, when the zero coupon yield curve is downward sloping, the yield to maturity will increase with the coupon rate. When the yield curve is flat, all zero coupon and coupon paying bonds will have the same yields, independent of these maturities and coupon rates. It's a little tricky with all these. This is a tricky chapter. All right, so as we have shown in this section, we can use the zero coupon yield curves to determine the price and yield to maturity of other risk-free bonds. The plot of the yields of coupon bonds of different maturities is called the coupon paying yield curve. When the U.S. bond traders refer to the yield curve, they are often referring to the coupon paying treasury yield curve. Notice the difference. Okay? Notice the difference. Treasury yield curve. As shown in example 6.8, two coupon paying bonds with the same maturity may have different yields. By convention, practitioners also plot the yield of the most recently issued bonds termed the on-the-run bonds. So this is an important term. Yield of the most recently issued is called the on-the-run bonds, okay? So just to let you know that. Using similar methods to those employed in this section, we can apply the law of one price to determine the zero coupon yields using the coupon paying yield curve. Thus, either type of yield curve provides enough information to value all other risk-free, and the important words are other risk-free bonds, okay? Other risk-free bonds. All right, so I'm going to stop there, and I will pick up here on the next part, okay?